Designing an effective protection against rainfall for Plyers Residing in Intramuros by Ashley Abigail Case. To give an overview to the flow of this presentation, here is an outline. Introduction, statement of the problem, concept and development, product operation, product and use, final design, and lastly, cost estimate. Introduction. So this is an aerial view of Intramuros. And inside Intramuros are schools, churches, offices, dormitories, residential areas, and tourist spots. That is a lot. And in fact, according to the Intramuros administration, 3.7 million tourists visited in the year 2019. That is equivalent to 1,200 to 1,300 tourists visiting each day. Intramuros has three modes of transportations: Kalesa, e-trike, and this one, the pedicab. In this presentation, we're going to focus on the pedicab. Statement of the problem. So these are the three types of protection that the Plyers are using. And the first is the common type of umbrella. Well, the second is the automatic. Third is the welded roof. The first two is made out of polyester shafts with microfiber fabric canopy. It is affordable, but it only lasts for a few months. While the welded roof is recommended by the IA, but it has to be welded, and it's durable, but it lacks the need to protect people. This is a data from the survey I conducted with the Plyers. This question is important because it helped us determine if the study is relevant. The data shows that 85% of the Plyers gets flu during rainy season. The other 5 had tuberculosis, 5% gets muscle pain, and the remaining 5% got mild stroke. The 5% who got mild stroke just then decided not to drive anymore for their safety. So by understanding the problems of these Plyers and considering the challenges and effects, we can produce an effective and necessary protection for them. Under design parameters would be ergonomics, function, and aesthetics. And under ergonomics, the product must follow the human factor guide so the product would be easy to access when it is needed to be used. It should not be too far or near, too high or low, and should not be interrupting the sight of the Plyer. Under function, must be able to rotate or slide without any complications for the Plyer. The components and how it must be manipulated should be obvious. And lastly, for the aesthetics, the protection must be clear, and the form should complement the pedicab. The water droplets must easily roll down the shield, so it will not interrupt the vision of the Plyer, and also it should not fog. Concept and development. Here is the compilation of concepts. And this is the consumer required feature analysis table. We considered adjustability, convenience, stability, design, and price as features because it is the top need of the Plyers. As you can see here, number 5 got the highest, which means that's what we're going to develop. Here is the compilation of development. And here we did the same. Here's the consumer required feature analysis table. This time we considered sustainability, durability, look, design, and price. And here, design number 2 got the highest score. So the features would be, it can be folded with knot in need, the visor is clipped and locked with pins, the visor is anti-fog, the visor is hydrophobic, and it can be attached to an existing welded roof. Here is the 3D rendering of the final design. And here is an exploded view for us to better visualize how to assemble the product and what it consists of. Here is an animation. Here is another animation, but this time the visor is connected to the roof, and then the roof is connected to the pedicab. And there's a person for us to see how far it gets when it's in the keeping position when you're not going to use it. Product operation. This is the clip. This is the stainless steel rod. These are the screws and nuts. This is the pin, female pin and the male pin. These are the clamps, and this one is the visor. And these are the steps on how to attach the product onto the welded roof. And this is the product in use. This is when you're not going to use it or when it's not raining. Technical drawings. This is the orthographic view and then the isometric view. And here is the components. Lastly, the exploded view. This is the price breakdown of our product. We've got item, quantity, price, and total. And then under item, we've got acrylic, stainless steel rod, screw, nut, hydrophobic coating, anti-fob, and 3D print plastic components. And under the labor requirements, since I got mine done in the Acrylics Manila, they charge 20 pesos per minute for the laser cutting machine, and then bending and labor 10 pesos per minute. It took the machine to cut the acrylic 1 minute, that's 20 pesos, and then bending plus labor 5 minutes, which makes it 50 pesos, and the total of this would be 912.